Hello guys, so today I'll be solving this problem which is smallest integer divisible by k. So the question states that we have been given a positive integer k and we need to find the length of the smallest positive integer n such that n is divisible by k, okay, and n should only contain 1, okay, and we need to return the length of n. So basically we have been given a positive integer k, okay, and we need to find a number that only contain ones, which means the numbers can be 1, 11, 111, okay, maybe 1000 and 111, okay, like that we will be going. So we need to find the smallest number, okay, which is divisible by k, okay, and we need to return the number of ones present in that, okay. So or we can say it like this: the minimum number of ones needs to be present in our n such that n mod k is equal to 0, or n is divisible by k. So yeah, that's the question. So one quick observation we can see that any positive even number cannot have a n, because so for a even number to satisfy, so it needs to be divisible by 2, right? So any even number can be represented in this form, 2 times m, and where m can be a whole number. So yeah, um, so we need we are looping over odd numbers, right? So no odd numbers are divisible by even numbers. So yeah, if k is even, we can directly return -1. And yeah, so that's the question also. So if we are not finding any such n, we have to return -1. So yeah, if k is uh, if k is even, so the answer is directly -1, okay. So now for odd numbers, how to solve this? So one way you can think of is we can simply generate this pattern, okay. So this is what, so this is a so this pattern is simply like we are starting with 1, we are multiplying it by 10, adding a +1, so this gives me 11. Similarly with 11, if I multiply it by 10, it gives me 110, and if I do a +1, so uh, this will be 111. So we can have a loop where we are keep on generating this number, and once we have found a number that is divisible by k, we will simply stop the loop, okay, and we will return the answer. That will work. But it may happen we are not at all finding any number, or the minimum number of ones is pretty large, okay, because if you look at the constraint, k can be 10 to the power 5, okay. K is less than so is within these bounds, okay. So if k is like 10 to the power 5, so generating a number like this uh, will be troublesome, okay. So it may happen this one can go to a pretty big large number. So yeah, this question is pretty similar to what we got the last day. So this problem, okay, so this was like previous day's LeetCode's daily problem, which is like binary prefix divisible by 5. So there also we were facing the similar issue, and if you watch my video, so I have given you a clear explanation and how to solve this kind of problem. So maybe around here I have given a proof also uh, how to solve this. So the key idea is we don't really need to store or we don't really need to generate all these numbers, okay. We only need to keep track of the modular value of the number, okay. So what does that mean? It basically means that, so whenever we are generating a number, so 1 to 11, or maybe oops, yeah, 1 to 11 or 11 to 111, okay, like this, okay. We don't really need to store this number, okay. We will simply store the uh, mod k value of this number, okay. So the proof of that I have shown in this video, so you can watch it, and I will also tag this video in my current video, so yeah, you can watch this video. So yeah, we can apply the same logic here, but now this question has a caveat, is that we will be generating this, right? So it may happen we are not at all getting any number. How to find that case, okay? So what can happen? So it may happen we are getting some modular value here, right? So let's say this is some m1 we are getting, m1 we are getting, m1 m2 we are getting, m3 we are getting, and let's say after some iteration again we encountered let's say m2, okay. So if we are getting a previously happened remainder, that basically means the cycle will again continue, okay. So if we are finding the same modulus again, then we will simply stop our iteration, and that basically means we haven't found any number that is divisible by k, and we will return -1, okay. So yeah, that's the core idea. So we only need to store the modular value of the number. So we will be generating this number by this logic, okay, multiplied by 10 plus 1, okay. But after this we will be doing a modulus over the number, okay, and we will be storing the remainder only, okay, because the question speaks about divisibility, okay, and it doesn't care about the number, it only cares about the length. So that basically means the number of iterations we are doing to generate or to get to a number whose modulus is 0, okay. So we don't really care about the number, we only care about the remainder of that number. So yeah, that's the core idea. So let's say I walk you through one of this example here. So let's say k equal to 3 here, okay. So k equal to 3, so let's start with 1, okay. So is 1 divisible by 3? Nope, okay. So we will update, or let's say this is our val, okay. So we're starting with 1, so 1 is not divisible by 3, okay, and its remainder is what, 1, okay. So then in our next iteration we will be doing times 10 plus 1, okay. This will get to 11, okay, and we will be storing the remainder of it, which is like 11 mod 3, which is what, 12, 1, again 1, okay. So oh yeah, the remainder is 2 here, yeah, cool. So 2, okay, still not 0, which means like 11 is not divisible by 3, okay. Now again let's do 10 plus 1, okay. So this will give me 111, okay. Now here if I check the remainder is 0, okay. That means the answer is this number, and the length of this number is basically the number of iteration I did, which is like 1, 2 and 3, okay. So 3 is my answer, as you can see here, okay. Now let's do a case where we have to return -1, which is this, okay. So let's say k equal to 2, okay. Again val and remainder. So yeah, let's do let's start with 1, okay. So when we divide 1 with 2, so the remainder is 1, okay. So it's not 0, so we have to do times 10 plus 1, so times 10 plus 1, so now it's 11. Now 11 we will be storing only the remainder, so 11 mod 2 is 1. Now we are getting 1 again, okay, which means this cycle will keep on continue, and we haven't found a number whose remainder is 0. This means I will stop my iteration here, okay, and I will return -1, okay, because I cannot get a number, and that also makes sense because here 2 is a even number, and as I explained you earlier, for even number the answer is not possible. So yeah, that's the idea. Now to have a track over the remainder, so you can use a set. Okay, that will work. So let's first try to implement it. Okay, so I'll start with C++. So let's say I store my answer as this. Okay, now this will keep track of the number of iterations I'm making. Okay, then I will create a value. Okay, so this value will store the number, but it will store only the remainder of that number. Okay, and then I will create a hash set or a set to store the remainders that I have gotten. Then I will say while finder.count, so while I haven't found this value yet. Okay, keep on iteration. Then yeah, and finally if I'm not if I'm not getting any answer in this loop, so I will simply return -1 here. Okay, now so I will update my visited. Okay, so I will say finder.insert val. Okay, then I will update my val as val times 10 plus 1. Okay, and I will do a mod of this. Okay, now I'll check if val is equal to 0. That means I have gotten a number which is divisible by k. Okay, and at every iteration I will be incrementing my answer. And yeah, if val is equal to 0, I will simply return my answer. Cool. If I run this, all test case pass. If I submit this, so this will work. Now so here the time complexity will be, so every time we are jumping by 10. Okay, but if you observe, we are doing this modulus k, right? Okay, and we have this search factor. Okay, now you can think of how much looping we will be needing. Okay, so what's the maximum time of iteration I will be doing? That is nothing other than k, because every time so when I'm doing this mod of k, that means I'm putting the value under k. Okay, because the mod k range is 0 to k minus 1. Okay, so my number will only lie between this. Okay, that means the maximum number of iteration that I can do is k minus 1, or like k times I will be doing. Okay, so yeah, because of this modulus, so the overall, so the maximum number of iteration I will be doing is k. Now there is other factor is this insertion. Okay, and this check, which are like logarithmic time complexity. So the overall time complexity will be so yeah, k log k. So yeah, that's my time complexity. And yeah, similarly for space complexity, you can think of like so how many numbers we will be storing. That is again the same thing, which is this range of mod k, which is 0 to k minus 1 numbers I can store at max. Okay, so this will be big O of k. Cool. Now since we know this fact that I will only require, like my numbers will only vary between 0 to k minus 1, that means I don't really require a set. Okay, I can do a constant time lookup. I don't need a set exactly. Okay, so I can have a hash set or a hash table by an array only, okay, of size k, and there I can simply check whether I have visited that value or not. So yeah, with that I will be reducing this logarithmic k lookup. So yeah, let's do that. So I can change this to vector of finder, and this is of size k. And here I will say if I haven't found val yet. Okay, let's make it boolean. Okay, if I haven't found val yet, then I will keep on looping, and at every iteration I will be setting val to true. So cool, this should work. Cool. Now if I submit this, this will be very fast. Cool. So yeah, 0 millisecond, but yeah, as I told you earlier, so never trust this graph. Cool. Now our improved time complexity will be big O of k only, because we have reduced this logarithmic time lookup to constant time, but still the space complexity will be big O of k. So yeah, we have an improvement of improvement on time complexity. Cool. Now let's do the same stuff in Golang. So yeah, I'll be creating an answer, and I will also creating an val, so 0 to 0. Then I'll be keeping a visited array, so I'll say visited, or I can use finder. So yeah, naming is just a convenience. So boolean, I will initialize everything to false. Then I'll say for while I have not visited val yet, okay, I'll say visited of val equal to true. Then I will update my val by this val equal to val times 10 plus 1 and val mod k. Okay, then I'll check if val is equal to 0, and yeah, before that I will be incrementing my answer. And yeah, if val becomes 0, which means I have gotten a number that is divisible by k, I'll simply return the length of that number. And if I am getting a reminder that I have visited earlier, so that means my for loop will break and I will reach at this stage. So that means I cannot find a number that is divisible by k. So yeah, I will simply return -1. If I run this, so yeah, cannot convert false. Oh yeah, here I should mention size. So of size k works, and let's submit. Cool. Now let's do the same stuff in Rust. So here I will create my mutable answer variable. Here also I will create my val as a mutable. Then I will create my visited array as a mutable array. So visited, I'll say back of size. So yeah, by default everything should be false and it should be of size k. Then I will say while I haven't visited val yet, so here I will say val as usize. And yeah, after this while loop iteration, if I am not getting a number, so I will return -1. Then here I will set my val as visited, so to true. Then I will update my val as val times 10 plus 1. Then I will update my val to modulus of k. Then I will increment my length or ans. Okay, now I will check if val is equal to 0. That means I have gotten a number that is divisible by k. Then I will simply return ans. Otherwise I will keep on iterating. Now if I got a reminder that I have visited earlier, which means I need to break out of this loop, and I will return -1. Cool. So this section is pretty identical to C++ and Golang. So just one thing we need to take care of this is val here I have declared as 0. So the compiler will think that because I'm using it as indices here, so it will automatically be treated as usize, which means this mod will fail because k here is i32. So I have to specifically say this is i32. So now if I run this, it fails. Yeah, because this also needs to be of size of data type usize. So yeah, let's submit. Let's run this. Cool. All test case pass, and let's submit. Cool. So yeah, this was the logic. So we only need to keep the remainder of the number that we are generating. And yeah, so to get the proof or the mathematical feeling of this concept, please watch this video. I will tag this video in my current video, so you can go through that. And yeah, the visited is just for storing what all remainders we have we are encountering. Okay, and yeah, cool. So I hope you learned the concept behind this question, and I hope this video will be helpful for you. So if you like this video, please do subscribe to the channel, and you can also comment in the video if you have any doubts. So I'll be happy to answer your questions. So yeah, just stay tuned to watch more videos, and bye bye.